So for today's video, I will do a um, summary of chapter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in one video. So let's get started. So first we have chapter 1. So explore the network. So we have our objectives. Explain how multiple networks are used in everyday. Explain the topologies and devices used in a small to medium-sized business network. Explain the basic characteristic of a network that supports communication in a small to medium-sized business. Explain trends in the networking that will affect the use of network in the small to medium-sized businesses. So, globally connected lands wants the internet network as a platform that changing network environment summary. So, globally connected, as you can see, this is the network in our past and daily lives. So, the global community networking impacts is not a we will not slide it. So, here's the example of network of many size. We have a small home network, small office, home office, and we have a medium to large network and worldwide network. So we have a client and servers, and we have a switch. So switch connected to the servers and client. So we have a peer-to-peer, as you can see in the figure. So I have files to share, and I have a printer to share. So it means it can print the files to the printer. So once the internet. So there are triggers network components. We have a devices, media, and services. So as you can see, here's the devices, the media, services. So end device is example of the end devices like we use is IP phone, PC, network printer. All device can um, has a barcode scanners. So example of intermediary. So we have the switches and wired access points, routers and firewalls. And we have a wire, copper wire, fiber optic, and wireless. So as you can see, here's the example of end devices. We have desktop computer, laptop, printer, telepresence endpoint, wireless tablet, and IP phone. So we have a intermediary devices, wireless router, multi-layer switch, LAN switch, firewall appliance, and router. We have network media and wireless media, LAN media, and WAN media. So we have a topology diagrams. We have two topology diagrams. We have a physical topology and logical topology. So types of network, we have local area network and wide area network. And then we have other types of network include we have a metropolitan area network and wireless LAN and storage area network. So a local, it has a network servicing home. So wired area network is LAN separated by geographic distance are connected by a network. Then the internet, as you can see, LANs and WANs may be connected to internetworks. So for the internet, it is the world. So extranet, it is the supplier and the customer. And for the internet, it is the company only. So connecting remote user to the internet, video, platform, cover network, planning, and scalability. So we do not we do not time to end this. So let's proceed to the chapter 2. So for the chapter 2, we have a operating system. All network equipment dependent on operating system. The operating system on home routers is usually called firmware. So iOS collection of network operating system used Cisco devices. So we have a two switch and two hosts. So switch 1 connects to the host 1 PC1 and switch 2 connected to PC2. We have a hardware, kernel, and shell. So first shell, the user interface that allows user to request specific tasks from the computer. And then kernels communicates between hardware and software, and hardware is the physical part of computer including underlying electronics. So purpose of OS PC operating system use a mouse, viewpoint, view output, enter text, switch or router. iOS provides option to configure interface, enable routing and switching function. All network devices come with default iOS. Possible to upgrade the iOS version. Then so this is this. So as you can see, we have a console access method. So most common methods to access the CLI, we have a console, telnet or SSH, and aux port. So console port device is accessible even if no networking services have been configured out of band. So need a special console cable. So as you can see, here's the console part. Console port. Then we have a telnet, SSH, and aux access method. So telnet method for remotely accessing the CLI over a network, secure shell or SSH remote login similar to telnet but utilize more security. So aux port out of band connection. So we have a accessing a Cisco iOS device. So we have a PATI, TerraTerm, Secure CRT, and Hyperterminal OS Hex Terminal. So we have a primary modes. We have the user exec mode. It is a limited examination of router remote access. So we have a privilege exec mode. It is the detailed examination of router debugging and testing file manipulation remote access. It is um, configuration and management command. So we have global configuration mode and sub modes. So privilege, it is the um, examination debugging testing as I explained to you. So we have a global configuration mode and commands. So other configuration modes. So we have a navigating between iOS modes. So router, console, shares now available. Press return to get started. So as you can see, we have a router. It is the user exec mode prompt. So second is the example of privilege exec mode prompt, and then user exec mode prompt. Let's proceed to the next. So we have a message size in chapter 3. So an overview of segmenting process. So the size restriction of frame require the source host to break a long message into individual pieces or segments that meet both the minimum and maximum size requirements. So we have a message timing, access method, flow control, and response timeout. So let's proceed. So network protocols house the message formatted or structured, formatted or structured. The process by which networking devices share information about pathway with other networks. So we have interaction protocol. Application protocol is hypertext transfer protocol or HTTP transport protocol, transmission control protocol. So internet protocol, network access protocol. So protocol suits the industry standards. Here's the example. So we have TCP IP protocol set and communication. So application layer, we have name DNS, and host config, we have BOOTP and DHCP. For email, we have SMTP and POP and IMAP. So file transfer FTP, TFTP, and last web is HTTP. For the transport UDP and TCP, and internet NAT, ICMP and RFP, OSP, PF, EIGR, RP, BGP, ARP. So network access, P, triple P, Ethernet, and interface drivers. So open standards, we have ISOC, IAP, and IETF. So here's the example. So we have the OSI model. So we have a 7 category. So first is physical, second data link, third network, four transport, five session, and six presentation, and seven application. So as you can see, benefits using the layered model. So for the application, for the OSI model, application and presentation and session has a HTTP, DNS, and DHCP, and FTP. For TCP IP model, it is an application only. And then transport network and TCP and UDP, it is also a transport. And for IPv4 and IPv6 and ICMPv4 and ICMPv6, it is internet and network. For the data link and physical and triple P frame relay and Ethernet, it is network access. So as you can see, we have 7. And application represent data user plus encoding the dialogue. Control transport support communication between diverse devices across diverse network. So internet determines the best path through the network. Network access control the hardware device and media that make up the network. So let's proceed to the uh, chapter 4. So here's the chapter for connecting the network. So as you can see, is the example of router. So it is the embedded wireless antenna, and then we have a 4/4 Ethernet switch, and then for the internet port connection. So as you can see, it is the wired LAN. So you must connect the wire to the Ethernet switch from your laptop. So we have a wireless LAN with range extended. So let's proceed. So the physical layer, as you can see, here's We have a copper cable, fiber optic, and wireless. So copper cable, we have a copper cable, fiber optic, and wireless media. Here's the physical component and frame encoding techniques and signaling and methods. So unit of bandwidth abbreviation. So equivalence. So bits per second, kilobits per second, megabits, gigabits, and terabits. So it's the physical media. We have a fast Ethernet switch ports, USB mini B connector, SHDSL interface management ports, gigabit Ethernet interface, and USB Type A connector. So characteristic of copper media, as you can see, it is the signal. All this is signal. Then copper media. So here's the UTP cable. Outer jack, twisted pair, and colored coded plastic insulation. So as you can see, we have a color coding here. It is the coaxial cable. So for cabling UTP, so RJ45 UTP plugs and RJ45 for UTP sockets. So for UTP cable, we have a color coding, which it is a common um, we have a color coding T568A and T568B. So I think it is common uh, for the uh, T T568B. So orange, white, orange, orange, white, green, blue, white, blue, green, and white, brown, brown. It is the common use uh, for our UTP cable coding. So properties fiber optic cabling. So enterprise network, fiber to the home, and long haul network submarines. So let's proceed to the chapter 5. So for the chapter 5, we have a MAC sublayer, so data encapsulation, frame assembly, before transmission, and frame disassembly upon reception of a frame. MAC layer adds a header or and trailer to the network layer PDU. So provides three primary functions. We have frame delimiting, addressing, and error detection. So MAC responsible for the placement of frames on the media and communicates directly with the physical layer. And then media access control carries sense multiple access and used to first detect if the media is carrying a signal, if no carrier signal is detected, and if two devices transmit at the same time. So we have media access control. So Ethernet encapsulation, early version of Ethernet were slow at 10 Mbps, 10 MB/s, now operate at 10 gigabits per second and faster. Ethernet frame structure adds header and trailers around the layer of 3 PDU to encapsulate the message being sent. Ethernet 2 is the Ethernet frame format used to TCP/IP network. So we have a Ethernet frame size, so destination, source address, and VLAN tag, type LAN data and frame check. So tag protocol user priority, canonical format indicator VLAN ID. So we have introduction of Ethernet frame, preamble, start of frame delimiter, destination address, source address length, and header and data frame check and sequence. So preamble and start frame delimiter fields used for synchronization between the sending and receiving devices. So we have a length type field defines the exact length of the frame data field describe which protocol is implemented. So data and pad fields contains the encapsulated data from a higher layer on IPv4 IPv4 packet. So frame check sequence used to detect errors in frame with cyclic redundancy check. So this is the MAC address and hexadecimal. So binary. So as you can see, MAC address representation. So here's for you to identify the MAC address. It is called a physical address. As you can see, we have physical address. So let's move on. So unicast, it is it is like man to man. So first we have a server, we have a host, one host. So we have a five we have a one source host and five hosts. So for the source host, it it uh, it come through with a server, only a server. So if broadcast it all the client, and the multicast is uh, we have destination host only. It is not a all host. So let's proceed to the next chapter. So we have a network layer protocol for chapter 6. Common network layer protocol include the IPv4 and IPv6. So legacy network layer protocol include the novel Inter-Network Packet Exchange, Apple Talk Connectionless Network Service. So IP components, then connectionless communication. So we have a letter sent in post box, and then it will deliver the letter to the destination. So the sender doesn't know if the receiver is present, if the letters arrive, if the receiver can read the letter. So the receiver doesn't know when it's coming. So best effort delivery. So here packets are routed through the network quickly. So some packets may be lost on route. So IP media independent. So we have a copper Ethernet from host to the router with a wide LAN copper serial, and then fiber optic IP packet, and then copper Ethernet through the wireless router, and then wireless router to the wireless PC. Encapsulating IP, transport layer encapsulation, and network layer encapsulation. So IPv4 packet header. So we have this contents of IPv4 packet header, and then contents of IP header fields. So sample IP headers. So we have a limitation of IPv4. So IP address depletion, internet routing table expansion, and lack of end-to-end connectivity. So here, introducing IPv6, increase address space, improve packet, eliminates that need for NAT, integrated security 4 billion IPv4 addresses, and 340 under zillion IPv6 addresses. So here's the encapsulating IPv6 packet header. Then we have a sample IPv6 header root. So host packet forwarding decision. So the IP address of router 1 interface is default gateway addresses for PC1 and PC2. So we have a local network root. We have 192.168.210.0. We have /20. So direct connection. So default gateway must maintain their own local routing table to ensure that the network layer paths are directed to the network destination network. So we have a direct connection, local network root, local default root. So let's proceed. So we have a IPv4 host routing table, then sample of IPv4 host routing table. So again, we have IPv6 host routing table, and then forwarding again. We have a router is a computer. So here's the CPU and OS. So we have router memory, we have memory, RAM, ROM, NVRAM, and flash. So volatile and non-volatile. So stores running iOS, running configuration file, IP routing, and ARP tables, packet buffer. So for ROM, boot up instruction, basic diagnostic software, limited iOS, and VRAM, start at config file, and flash we have iOS address system. So let's proceed to the next chapter. So we have a positional notation for chapter 7. So the first row identifies the number base radix. So second row is the position number, and then calculate, and then positional value. So positional notation count, then applying binary position notation. So binary to decimal conversion, to convert a binary IPv4 address to decimal, enter the 8-bit binary number of each octant under the positional value of row 1, and then calculate the produce the decimal. So as you can see, we have a 11000000. It means here 192 128 plus 6 plus 192, and then we have the 101010. So it means 1, then 128 plus 34 32 plus 8 is the answer of this. Let's proceed. So decimal to binary conversion. So to convert decimal IPv4 address to binary, is the position chart. So for the summary of this, so if the n is greater than or equal, so the positional value is, you have to add 1. So you will uh, put 1 for this 128 and the rest is 0. For example, for example, 192. So 192 minus 128, and then you have to put 1 because it can, I said earlier, it is greater than or equal. So you have to put 1, and then second you have to subtract 192 for 128, and the answer of this, if the answer uh, of 192 and 128 is greater than or equal again to the 64, it can add again. Then let's proceed. So network and host portion. An IPv4 address is hierarchical, composed of network portion and host portion. All devices on the same network must have the identical network portion. So the subnet must help devices identify the network portion and host portion. So the three IPv4 address must be configured on host. A unique IPv4 address of the host subnet must identify the network host portion of the IPv4 address and default gateway IP address, the local router network. Subnet must be. So for the logical, if it's a one, if it is a one in the bits yields it is one. So if you see a zero, it automatically zero. So it is the prefix length shorthand method of expressing the subnet. So written in slash notation followed by the number of network bits. So let's go to the next chapter. So public and private IPv4 addresses in chapters 8. So private address blocks are hosts that not require access to internet can use private addresses like 10.00, 10.0.0.0 to 10.255.255.255. It means 10.0.0.0/8. So shared addresses, space addresses, not globally routable, intended only for use in service provider networks. So for address block is 100.64.0.0/10. So special use for IPv4 address, network and broadcast addresses. Within each network, the first and last addresses cannot be assigned to host. Loopback addresses. So 127.0.0.1 is special address that hosts use to direct traffic to themselves. So addresses 127.0.0.0 to 127.255.255.255 are reserved. For the link local addresses is 169.254.0.0 to 169.254 to 255.255. So addresses can be automatically assigned to the local host. So testnet addresses, we have a 192.0.2.0 to 192.0.2.255. So set aside for teaching and learning purposes, used in documentation and network examples. So experimental addresses 244 and so on are listed as reserved. So legacy class full addressing. So classes addressing, formal name is classes interdomain routing or pronounced cider. So created a new set of standard that allowed service providers to allocate IPv4 addresses on any addresses bit boundary prefix length instead of only by a class A, B, or C addresses. So, regional internet register. So, for need for IPv6, we have designed to be successor to IPv4. Depletion of IPv4 address projection showed that all 5 RIRS will run out of IPv4 address. So, within an increased internet population, so IPv4 has theoretical maximum of 4.3 billion addresses. IPv4 larger than 128 bits. So IPv4 fixes the limitation of IPv4 and includes the additional so enhancements such as ICMPv6. So we have dual stack allows IPv4 and IPv6 coexist on the same network. So here's the chapter summary of chapter, and then we have to proceed to the next chapter. So reason for subnetting for chapter 9, and subnetting is the process of segmenting a network into multiple smaller network spaces called subnetworks or subnets, and then communication between subnets. A router is necessary for devices on different networks and subnets, and each router interface must have an IPv4 host addresses belongs to the network or subnet that the router interface is connected. So plan network. So basic subnetting, borrowing bits to create subnets, borrowing 1 bits 2 raised to 1 and equals to 2 subnets. So as you can see, subnet new is subnet 0, we have network, subnet 1. So calculate number of subnets. So 0 is the subnets borrowed. So creating 4 subnets, borrowing 2 bits to create 4 subnets. So as you can see, here's the 8 subnets. So subnetting based on host requirements. So consideration when planning subnets. Number of subnets required, number of host addresses required. So formula to determine number of usable hosts 2 n minus 1. So 2 where n is the number of remaining host bits is used to calculate the number of hosts. So negative 2. The subnetwork ID and broadcast address cannot be used on each subnet. So calculate the subnet. So if you know how the formula, you will calculate the subnet. So let's proceed to the next chapter. So we have application layer for chapter 10. So closest to the end user, used to exchange data between programs running on the source and destination host. So presentation and session layer. So presentation layer function formatting data at the source device into compatible form for the receiving device, compressing data and encrypting data. So per session layer function create and maintain dialogues between source and destination application. So as you can see, we have a TCP/IP application layer protocol. So as you can see, again, client and server process are considered to be in the application layer. Application layer protocol describe the format of the requests and responses between clients and server. So example of the client server, so network is using the ISMP email service, send, receive, and store email. So peer-to-peer, it has the data is accessed from peer device without use of dedicated server. Each device, known as a peer, can function as both server and client. So peer-to-peer application. So a P2P application allows a device to act as both a client and server within the same communication. So P2P application require that each end device provide a user interface and run a background service. So hypertext transfer protocol and hypertext markup language. So when a web address or uniform resource locator URL is typed into the web browser establishes a connection to the web service running on the server using the HTTP protocol. So here's the summary of chapter 10, and let's proceed to the next last chapter. So here's the last chapter for summarize all chapter 1 to 11. So chapter 11, IP addressing for a small network. So IP addressing scheme should be planned, documented, and maintained based on the type of devices receiving the address. So for example, device that will be part of IP design, we have end user, end device for user, server, and peripherals, hosts that are accessible from the internet, intermediate devices. So planned IP schemes help the administrator track devices and troubleshoot and control access to resources. So redundancy in a network, small network. Redundancy helps to eliminate single points of failure, improve the reliability of the network. So design consideration for small network. So we have a common application in small network. We have a network aware application. So for software programs that are used to communicate over the network, application layer services, programs that interface with the application with the network and prepare the data for transfer. So network protocol process on either end of communication session, types of messages, syntax of message, meaning of informational fields, how messages are sent and expected response, interaction with the next lower layer. So let's proceed again. So real-time application for small networks. So infrastructure needs to be evaluated to ensure it will support proposed real-time application. So VoIP is implemented in organization that is still use traditional telephones, and then IP telephony, and the IP phone itself perform voice to IP conversion, and then real-time video protocol use time transport protocol and real-time transport control protocol. So this is the end of my video, and I hope you enjoy watching. And again, here's the summary of chapter 1 to 11, and thank you. Bye.